In the limitlessness of the universe, humankind has just started to expose investigation. In spite of our restricted information, we have long considered the chance of extraterrestrial life, frequently engaging the possibility that we may be distant from everyone else in the universe. In any case, an outlook-changing occasion happened with the appearance of our most memorable interstellar guest, Oumuamua. Not at all like anything we had experienced previously, this puzzling object left us in wonder of the possibilities that lie beyond our reality. As of late, famous astrophysicist Neil deGrasse Tyson stunned the world by revealing never-seen-before declassified pictures of Oumuamua. What elements are answerable for sending this extraterrestrial courier? What is the YP impact, and what does it have to do with Oumuamua? Join us as we adventure into the profundities of space, moved by the information shared by none other than astrophysicist Tyson. Unveiling the mystery behind this peculiar interstellar voyager, back in 2017, a historic disclosure was made that changed our impression of our spot in the huge universe. Utilizing the Pan-STARRS 1 telescope, astronomers looked profound into space and found a surprising object floating towards Earth. The visit of the puzzling flying object known as Oumuamua prodded a significant upheaval in our impression of space and its vast possibilities. Notwithstanding its widespread fame, our knowledge of this mysterious object has remained limited due to public interest. The eminent astrophysicist Neil deGrasse Tyson has revealed previously undisclosed and highly classified pictures of Oumuamua. Using his expertise, Tyson has shed light on this enormous discovery, unveiling its significant ramifications for our local planetary group. Notwithstanding, before diving into the complexities hidden within these long-protected pictures, it is essential to initially explore the captivating nature of this mysterious heavenly object. On October 19, 2017, astronomers at the Haleakala Observatory, Hawaii, made the historic observation of what they initially believed to be a comet or a space rock. However, further examination revealed that it was, in truth, the very first interstellar object identified within our local planetary group. Barring dust grains, the object's skewed circle and rapid speed led scientists to reason that it originated from beyond our planetary group, prompting them to assign the Hawaiian name Oumuamua, signifying a courier from afar. Showing wild swings in brilliance of up to 2.5 extents, Oumuamua displayed an exceptionally extended shape with a length 5 to 10 times greater than its width. The peculiar state of this baffling flying object ignited numerous speculations and theories aimed at unraveling its origin and the purpose of the visit. One hypothesis suggests that Oumuamua's length and shape might result from flowing powers. When an object passes close to a star, the gravitational forces applied on it can cause significant extending. This flowing extending could account for Oumuamua's stretched, stogie-like appearance. However, this explanation faces challenges in figuring out the specific aspects and extent observed in Oumuamua. To obtain further insights into Oumuamua's shape, astronomers have directed their attention to similar objects within our planetary group. One such object is the space rock 25143 Itokawa, which was visited by the Japanese Hayabusa shuttle in 2005. Itokawa displays a prolonged shape resembling a rough diamond or a potato. Concentrating on Itokawa's shape and surface features has provided valuable information about the cycles involved in forming and evolving such objects. However, while Itokawa shares some similarities with Oumuamua, the interstellar guest remains distinctive in its extended expanse and absence of a tail. Oumuamua's unique acceleration, which is like a bike suddenly gaining speed without accelerating, adds a charming element to its character. After entering our local planetary group from over the plane where planets circle, it moved exceptionally near the Sun, reaching around 1/4 of the Earth-Sun distance. Following this close encounter, the vast explorer proceeded with its direction below the planetary plane. It is genuinely surprising that Oumuamua kept an unquestionably fast speed, getting started at around 196,000 miles per hour, indicative of a significant amount of motor energy throughout its journey. To place this into perspective, its speed exceeds that of any human-sent object, including spacecraft and satellites. This high speed has led to the speculation that Oumuamua might have originated from a binary star system. The hypothesis suggests that gravitational interactions within binary star systems can release objects at high speeds. Assuming that Oumuamua did indeed originate from such a system, it is possible that the gravitational forces exerted by the stars pushed it on its interstellar journey, explaining its striking velocity. Another possibility suggests that Oumuamua's speed was a result of interactions with other celestial bodies in its home star system. Encounters with planets or other sizable objects might have acted as gravitational slingshots, pushing Oumuamua to its notable speed. However, further investigation is necessary to determine the likelihood of such encounters and their contribution to Oumuamua's speed. Nonetheless, there's more to Oumuamua besides its speed. Studies have revealed fascinating insights into its composition. It has a thick outer layer, like a cosmic shell made of carbon-rich materials that set due to cosmic radiation during its extensive travels through interstellar space. Beneath this protective exterior, Oumuamua reveals its extremely dense inner nature, primarily made out of rock and possibly containing elements of metal. What sets it apart is the absence of water or ice, which distinguishes it from typical comets or cold celestial bodies. Moreover, Oumuamua's surface has a ruddy color resulting from prolonged exposure to cosmic rays over thousands of years. Researchers have also considered the possibility that Oumuamua's rapid is a result of its shape and composition. Then again, some people have mentioned the contribution of famous specialists like Neil deGrasse Tyson and Michio Kaku to the conversation around Oumuamua. Strangely, Neil deGrasse Tyson avoided commenting on this issue until significant evidence and the new declassified photographs became available, leaving everyone anxiously awaiting his viewpoint on the matter. Some scientists suggest that the object's elongated structure, as derived from its light curve, shows that it could be a part of a larger body. Assume Oumuamua severed from a larger object due to a collision or other violent events. All things considered, it could have gained significant speed during the detachment process. This would suggest that Oumuamua's speed isn't intrinsic to its nature but rather a result of previous events. Comets, for example, cross our planetary group at various speeds. While certain comets can achieve speeds similar to Oumuamua's, for example, Comet Hale-Bopp, they typically exhibit leftover gas and dust due to their consistent formation. Interestingly, Oumuamua showed no such attributes, distinguishing it from known cometary objects. One more comparison can be made with asteroids, rocky objects that circle the Sun. Most asteroids in our planetary group move at significantly slower paces than Oumuamua. For example, the typical orbital speed of the notable asteroid series is roughly 25,200 kilometers per hour, under a fifth of Oumuamua's estimated speed. This divergence underlines the outstanding nature of Oumuamua's speed and its differentiation from typical local planetary group objects. Here's where things become much more interesting. Some specialists hypothesize that Oumuamua could be more than a naturally occurring object. They propose that it could be an artificially created creation, meticulously made by a high-level extraterrestrial civilization. Oumuamua might be part of an extremely advanced alien spaceship or equipment designed for exploration. According to this hypothesis, Oumuamua's special features could serve multiple functions. Its elongated structure could enhance its maneuverability during interstellar travel, while its propulsion system could enable precise maneuvering through the cosmos. Popular figures like Avi Loeb, an Israeli-American theoretical physicist and astronomer, strongly believe this theory. Loeb even proposed a controversial hypothesis that Oumuamua could be of extraterrestrial origin, suggesting that it could be an artificial object or even a piece of alien technology. He argued that its peculiar properties, such as its elongated shape and unusual acceleration, could indicate an artificial origin. Loeb's hypothesis generated widespread discussion and debate within the scientific community. Nonetheless, it is essential to take note that numerous researchers and space experts have expressed doubt about his claims. The common view among most researchers is that Oumuamua is probably a natural object like a comet or a space rock, with its surprising properties being the result of natural cycles. Wesley C. Fraser and other scientists combined brightness measurements from various telescopes to examine a spin period. That's what they reasoned. No revolution period can account for the observed brightness variations. All things considered, the object appears to be tumbling in an excited rotational state. This strange, unconventional tumbling motion was unlike anything seen previously. This irregular spin has puzzled scientists since its discovery. Observations made by astronomers have provided valuable insights into Oumuamua's twist. It completes a full rotation every 7.3 hours, which is relatively fast compared to the rotational times of other objects in our local planetary group. Moreover, its brightness varies significantly as it turns, indicating that different parts of the object reflect sunlight to varying degrees. This irregular rotation has confounded scientists and led to various interesting theories. One hypothesis proposed to make sense of Oumuamua's twist is the outgassing hypothesis. As per this idea, volatile substances beneath its surface are exposed to solar radiation as the object tumbles through space, causing it to sublimate and create small gas jets. These jets act as engines, imparting a force on Oumuamua and causing it to tumble erratically. This suggests that Oumuamua's structure might contain volatile materials, susceptible to sublimation induced by solar radiation. However, further investigations are needed to confirm if this mechanism is responsible for Oumuamua's curious rotation. Another hypothesis suggests that Oumuamua's tumbling motion could result from a previous impact with another object. It is possible that a high-speed impact distorted its shape and set it into an irregular spin. This impact could have occurred in the object's home star system before being catapulted into interstellar space. However, the exact nature of such an impact and the object involved remain speculative due to limited observational data. Detailed examination of Oumuamua's shape, composition, and surface features could provide clues supporting this hypothesis. To better understand Oumuamua's particular evolution, let's look at other celestial objects with similar behavior. One such object is the asteroid 4179 Tatatis. This elongated asteroid, discovered in 1989, displays a tumbling motion much like Oumuamua. Researchers have proposed several hypotheses to make sense of Tatatis' whimsical behavior, including its irregular shape and unusual rotation. Nevertheless, the mysteries surrounding Oumuamua continue to captivate the scientific community, prompting further investigation into its origin and nature. As we delve deeper into the enigma of this interstellar visitor, we may uncover profound insights into the mysteries of the cosmos and our place within it.